So this is going to be the third and final part of the first part of 4.3. I do want to go back. I forgot to put coordinates in for 0, 90, 180, and 270 for the angles that fall on the coordinate plane. So let's put those in really quickly. Okay, so let's start with a 0-degree angle. A 0-degree angle would have both the initial side and the terminal side on the x-axis. It would intercept that unit circle at this point right here, okay, at the point, this is the point 1, 0. Okay, this 90-degree angle right here, the terminal side would intersect the unit circle at 0, 1, right? So the initial side would be here on the x-axis, the terminal side would come up here and intersect the unit circle at 0, 1. For 180, that's a straight angle, so your initial side would be here on the x-axis. Your terminal side would intersect the unit circle at -1, 0. Okay, and then this 270 angle, your initial side would be here and your terminal side would be right here, okay, at 0, -1. Okay, and just so you see those, you're in a 0-degree angle, right? Here's your initial side, but your terminal side wouldn't go anywhere. Here's your 90. It's really hard to see since there's so much stuff on the unit circle. It would look right like this. Your 180 is straight. And then your 270, right, so here's 0. It's going to intercept that unit circle at 1, 0. Here's 90, right? It's going to intercept the unit circle at 0, 1. Here's 180, the terminal side is going to intersect the unit circle at -1, 0. And then a 270, here's my initial side. I go all the way around 270 degrees. Okay, so that's going to intercept that unit circle at 0. Okay, so how do we use this? Okay, we need to go back, remember, to this, where we said the sine of the angle is the y-coordinate, cosine is the x, and tangent is y over x. Okay. All right, so if we want to find some exact values of angles, okay, and this is the only example we're going to do. Okay, so we're going to evaluate without a calculator. We're going to give exact, so no decimals, answers. Okay. All right, so it's kind of messy. I'm going to erase that, but remember that, okay? All right. So let's start with, for example, the sine of 45 degrees. Okay, remember sine is the y-coordinate. Okay, so if I find this 45-degree angle, which is right here, to calculate the sine, I just need the y-coordinate of the angle. So the sine of 45 is going to be square root of 2 over 2. Okay, and I can't get an exact answer if I put that into my calculator. Okay, so you have to use this unit circle. So sine of 45, right, if I put that on my calculator, it's 0.707. I can verify that it's square root of 2 over 2 if I know that. Okay, so I can verify that, but the calculator is not going to tell me that. So to get an exact answer, I've got to know that unit circle. Okay, let's say that I want to find the cosine of 5 pi over 6. Okay, so cosine of 5 pi over 6. I'm going to go back to my unit circle. Here's 5 pi over 6 right here. It's 150 degrees. Cosine is the x coordinate, and so in this case it's negative square root of 3 over 2. Okay, so the cosine of 5 pi over 6 is negative square root of 3 over 2. Okay, let's look at the tangent of 225 degrees. Okay, so the tangent of 225, there's 225. To find tangent, I do y over x. Okay, so negative square root of 2 over 2 divided by negative square root of 2 over 2. Okay, and anything divided by itself is 1, so that I'm just going to make 1. Okay, let's look at the tangent of 330 degrees. Okay, so let's do tangent of 330 degrees. Okay, so tangent of 330 is y divided by x. Okay, so it's negative 1/2 divided by the square root of 3 over 2. Okay, when I divide fractions, I take the numerator and I multiply by the reciprocal of the denominator. Those cancel out, and I have negative 1 over the square root of 3. Okay, however, when we give these answers, we really need to rationalize the denominator. Okay, we want that square root, that radical, out of the denominator. So to do that, I'm just going to multiply the top and the bottom by the same thing that's in the denominator. So this would be negative square root of 3 over 3. Okay, and again, you can use the calculator to verify this, but it's not going to give you the exact answer. So I can go to my calculator and put tangent of 330 degrees in there, and then I got, for my answer, negative square root of 3 over 3. Right, so I can verify that that's what it is, but to get that exact answer, I've got to use the unit circle. Okay, let's just look at a few more and then we'll be done. Letter E, let's find the sine of pi over 2. Okay, sine of pi over 2. Okay, sine is the y coordinate, so the sine of pi over 2 is 1. Okay, let's look at the cosine of pi over 2. Okay, so cosine is the x coordinate, so in this case it would be 0. Okay, and then last, let's look at the tangent of pi over 2, or 90 degrees. Okay, so the tangent is y divided by x. Okay, however, right, I can't divide by 0, so the tangent of 90 degrees is actually undefined. Okay, so you have a worksheet. It really shouldn't take you long today to work through, okay, these problems. There's 20 problems in there. Okay, so you have a worksheet to work through. There's 20 problems in that. Okay, you also have videos in here. I'm going to put the 3 videos for this lesson and then 1 extra video in here. Again, it's just somebody setting up the unit circle. I think it will be easier to watch how she sets it up, but I like the way that I showed you because I want you to understand why it is the way that it is. Okay, so how do we come up with all of these numbers? So you get the mathematical understanding behind it. Okay, that is all we have for today. So good luck and let me know if you need help.